I am quickly running out of time to get this new manuscript finished. I now have a more or less complete working draft, but there's plenty of editing left to do. In the end, the paper might not focus on electromagnetic theories to the extent that the editors want it to. The central thesis I make is that a good theory of consciousness should position the correlates of conscious content within the correlates of the conscious state. Ultimately, this is as much a challenge to network theories as it is to field theories. I highlight my own theory, the TICL, and 5 others, and compare how they stand up in terms of explaining the unified and compositional nature of consciousness as we know it. I find that certain theories of consciousness are better able to reconcile with my model, and they do not fall along network versus EM field theories. By the time I'm preparing the next podcast episode, I hope to have that thing done and dusted. I've been spending a lot of time on it. The next phase will be to see what the editors have to say. Either they'll send it for review, or they'll scrunch up their faces and say, "What the hell is this?" Wish me luck on getting the first reaction. In 2019, a paper came out in Consciousness and Cognition titled The Unfolding Argument, Why IIT and Other Causal Structure Theories Cannot Explain Consciousness by Adrien Doerig, Aaron Schurger, Kathryn Hess, and Michael Herzog. I've spoken at some length about integrated information theory, IIT, in the past, and I've given it plenty of criticism. But here the authors marshal what they call the unfolding argument against all causal theories of consciousness, including, for example, Victor LeMay's recurrent processing theory, and my own temporally integrated causality landscape, TICL. In particular, the TICL says that consciousness of content occurs in accordance with the spatially and temporally embedded activities of neurons which have sufficient temporally integrated causality to be distinguishable from background noise. The theory suggests that this is accomplished by means of having a large integrated system in the brain's thalamocortex, inside of which there are subsystems, which are smaller collections of neurons influencing one another to an even higher degree. The system experiences the dynamics of the subsystems. In fact, the identity of consciousness itself in the TICL is a landscape of temporally integrated causality. What is causality? It is an exchange of energy or physical information. The system unites all of the contents of consciousness, so from the point of view of the system, the subsystemic activities are contents in consciousness. Naturally, an argument disfavoring causal theories of consciousness is worth my attention when it shows up in the literature. So let's take a look at the unfolding argument and find out whether I had better get back to the old drawing board. Doerig et al. Write, quote, "Recurrent neural networks are universal function approximators. That is, any input-output function can be approximated to any degree of accuracy. Vision is such an input-output function. For example, pictures of animals are presented as inputs on the retina, and the outputs are the elicited percepts of animals, or reports about these percepts. Likewise, the stimuli in a visual masking experiment are inputs, and the outputs may be button presses, verbal reports, or any other measure shown to reliably correlate with subjective reports. Importantly, experiments which intervene directly on the brain, for example using implanted electrodes, or transcranial magnetic stimulation, TMS, are still input-output functions. The only difference is that part of the input is provided by means of electrodes, or TMS, rather than through the sensory organs. Feed-forward neural networks are also universal function approximators. Both recurrent networks and multi-layer feed-forward networks are universal function approximators. That is, they can be used to generate any desired input-output function to any degree of accuracy using a finite number of neurons. Therefore, for any recurrent network with a given input-output behavior, there are corresponding feed-forward networks with the same characteristics, although feed-forward networks often need many more neurons than their recurrent counterparts. For example, recurrent networks performing image recognition, exhibiting binocular rivalry, and processing spike trains all have feed-forward equivalents. Anything that can be done by recurrent networks can also be done in a feed-forward manner. Hence, for a given input-output function, we can find both feed-forward and recurrent networks that realize the same function in different ways. For instance, if there is a recurrent network that performs image recognition, there is an equivalent feed-forward network that does it equally well. If there is a recurrent network that exhibits the characteristics of binocular rivalry, there is an equivalent feed-forward network that does so too. If there is a recurrent network that takes a collection of spike trains as inputs and outputs another collection of spike trains, there is an equivalent feed-forward network that does the same thing. Anything that can be done by recurrent networks can also be done in a feed-forward manner. We call this unfolding. Any recurrent network can be unfolded into a feed-forward network implementing the same function. In particular, any behavioral experiment can be seen as an input-output function and can thus be implemented by both recurrent and feed-forward networks." Unquote. The authors conclude that causal structure theories are either false or outside of the realm of science. I accept the premise that any computation which can be accomplished by a recurrent or integrated network configuration can be achieved by a different linear computation. So given a certain input of data and an appropriate output of data, an algorithm could be constructed that could do the job in a step-by-step fashion. In the case of complex operations like facial recognition or comprehending language, this will require a very high number of steps, maybe millions of steps, I don't know. But this is obvious, isn't it? It might be totally inefficient for a biological system like the brain to use this kind of computation, and therefore impractical by means of natural evolution. But of course modern computers can eventually simulate and even go beyond the cognitive capabilities of the human brain. Here is the structure of the argument as presented by the authors. Quote, "To summarize the unfolding argument, the conclusion follows from 4 premises. 1. In science we rely on physical measurements, based on subjective reports about consciousness. 2. For any recurrent system with a given input-output function, there exist feed-forward systems with the same input-output function, and vice versa. 3. Two systems that have identical input-output functions cannot be distinguished by an experiment that relies on a physical measurement, other than a measurement of brain activity itself or of other internal workings of the system. 4. We cannot use measures of brain activity as a priori indicators of consciousness because the brain basis of consciousness is what we are trying to understand in the first place. Therefore, either causal structure theories are falsified, if they accept that unfolded feed-forward networks can be conscious, or causal structure theories are outside of the realm of scientific inquiry, if they maintain that unfolded feed-forward networks are not conscious despite being empirically indistinguishable from functionally equivalent recurrent networks." Unquote. I am conscious. I know this is a matter of fact, just as Descartes did. In principle, I don't know if you or anybody else is conscious. We assume that other people are conscious, and we extend that to assume that other related animals with similar brains are conscious. Other people wake up and go to sleep. They walk, they talk, they engage in different activities. When I do those things, I am conscious. It is like something to walk and talk and engage in the activity of life. I make the inference that it's like something for other people too. This is perfectly reasonable and the best we can do until we have a means of detecting consciousness using scientific methods. I admit this. The inputs and outputs of a system can't possibly tell us whether it is like something to be that system. This is why the Turing test of general artificial intelligence is flawed. John Searle illustrates this better than anyone. Searle wrote in his book, The Mystery of Consciousness, quote, "The important point is that the mechanism is defined entirely in terms of the manipulation of symbols. Computation so defined is a purely syntactical set of operations, in the sense that the only features of the symbols that matter for the implementation of the program are the formal or syntactical features. But we know from our own experience that the mind has something more going on it than the manipulation of formal symbols. Minds have contents. For example, when we are thinking in English, the English words going through our minds are not just uninterpreted formal symbols. Rather, we know what they mean. For us, the words have a meaning, or semantics. The mind could not just be a computer program because the formal symbols of the computer program by themselves are not sufficient to guarantee the presence of the semantic content that occurs in actual minds." Unquote. Searle's point is just like I said. No output from a system, given input, can show us that it is like something to be that system. Now that we have sophisticated computer programs, of course problems will be solvable by them. Take math, for example. What's 71 plus 13? Notice that it is like something for you to do this calculation. It might be different for one person or another in terms of what it is like, but it is like something in any case. A basic electronic calculator can answer this question if we punch in the numbers. Obviously, the pocket calculator is not conscious. A set of electronic events are triggered by the buttons and the display shows their result. Nowadays, you could have a device which takes voice commands to do the same thing. You say out loud, 71 plus 13. And this newer calculator answers out loud, 84. The addition of voice recognition is a difficult technical feat requiring a lot more processing power than an old school calculator, but it's the same kind of thing. It isn't like something for this device to do the calculation. From the user's point of view, it's just spoken input and spoken output, but what is happening inside makes a difference. The system is not conscious just because it does complex operations. So are we going to be surprised in a few years when a computer like this can have basic conversations? This would be a big advancement, and it might be able to fool a judge into believing he was communicating with a real person. So what? That doesn't make the computer conscious. Is this controversial? John Searle's Chinese room thought experiment distinguishes between computation as it occurs in Turing machines and mental processes in consciousness. He wrote, quote, "Imagine that you carry out the steps in a programming for answering questions in a language you do not understand. I do not understand Chinese, so I imagine that I am locked in a room with a lot of boxes of Chinese symbols, the database. I get small bunches of Chinese symbols passed to me, questions in Chinese, and I look up in a rule book, the program, what I'm supposed to do. I perform certain operations on the symbols in accordance with the rules, that is, I carry out the steps in a program, and give back small bunches of symbols, answers to the questions, to those outside the room. I am the computer implementing a program for answering questions in Chinese, but all the same, I do not understand a word of Chinese. And this is the point. If I do not understand Chinese solely on the basis of implementing a computer program for understanding Chinese, then neither does any other digital computer solely on that basis, because no digital computer has anything that I do not have." Unquote. This thought experiment clearly illustrates the difference between syntax, which are symbols, and semantics, which have meaning. Likewise, the voice recognizing calculator that I brought up before does not understand English. It isn't thinking. Doerig et al. Come to the conclusion that causal structure theories are either wrong or outside of the scientific realm. Their argument is structured like this. 1. Science relies on physical measurements. They specify that this comes down to subjects reporting on their conscious experience. That is a really limited view on science, and I think it cooks the failure right into the premise. We already know that you cannot determine consciousness in a system based on its outputs given a set of inputs. We have no way to do this, and we would be foolish to think otherwise. Even if modern computers are using the same basic operations in ones and zeros that they were doing back in the 70s, the computational speed is so much better now that we can expect computers to be able to calculate and simulate more and more of what humans can do. But at no point should they become conscious as long as they are just doing more of the same thing. Never mind causal theories of consciousness, no theory of consciousness will be able to use subjective reports to prove that it is like something to be the subject. 2. Any recurrent system with an input-output function can be mimicked by a feed-forward system, so that the inputs and outputs are the same. I accept that. It doesn't do the work the authors think, though. The human brain contains all kinds of networks, feed-forward as well as recurrent. It's not as if theorists are just guessing about the recurrent characteristics of the conscious brain. We observe that feed-forward structures like the cerebellum, the spinal cord, and the primary visual cortex do not produce conscious content. These structures are neither necessary nor sufficient for conscious content. The parts of the thalamocortical system responsible for conscious contents are reciprocally interconnected structures. Such evidence, while circumstantial, must be taken into consideration. 3. Two systems with identical inputs and outputs cannot be distinguished without looking at the internal mechanisms. Yeah, that's true. It's the same point as number 1. You can't use subjective reports to prove that it is like something to be the subject. 4. Measurements of brain activity cannot be used to indicate consciousness because the basis of consciousness in the brain is what we are trying to understand. This last statement makes sense, but only in part. If I want to understand how a calculator does what it does, I have to take it apart and reverse engineer it. Neuroscience is attempting to do that with the brain, and contrasting conscious versus non-conscious states is a damn good start. With science narrowly defined as the authors do, their conclusion is warranted. They conclude that either causal theories are false, or they're outside of the realm of science. In order to falsify the causal theories, we would have to conclude that feed-forward systems are just as capable of consciousness as recurrent systems. I can't conclude that based on evidence or theory. So the alternative is that causal theories are outside of the realm of science. Given that science is narrowly defined as the observation of behavioral output given a stimulus, this conclusion can be made of all theories of consciousness. There is a reasonable case to be made one that's been made before, that consciousness can't be explained scientifically. In a sense, the problem is built into the structure of the scientific method. The purpose is to make observations and hypotheses that can be tested by objective methods. It's no small challenge to put on a productive investigation of subjectivity using objective methods. That's why this is a hard problem. There is no doubt that we are as much in the realm of philosophy as we are in the realm of science. Science-backed analytical philosophy is probably a good description of these theories. As a direct attack on causal theories of consciousness, I'm not troubled by the unfolding argument. In fact, my theory does predict that causality is central to consciousness as a property of the brain. This is why. Consciousness is a composition of contents that exist from one unified point of view. Consciousness exists undeniably. For something to exist in the physical sense is for it to be affected by physical processes or able to affect physical processes. It has to be part of the causal chain. For example, matter is known to exist because we can measure its mass. Stars certainly exist because they have gravitational effects and they emit photons. Sometimes we infer that something exists because there is a measurable effect, but we don't have an explanation for it. Dark matter is such a phenomenon. Our own consciousness is such a phenomenon too. We infer our existence from the fact that we are experiencing content. We are thinking and feeling and perceiving. A system which is not integrated is only a system from an objective outside perspective. Take a body of water, for example, or a cloud, or a mountain. Is a mountain a thing or just a description of a kind of geometrical feature that occurs in the Earth's crust? Where does one mountain end and another one begin? Consciousness is a unified phenomenon, so it should correlate with an integrated system or process. That means that it should involve an exchange of causal interactions among its parts. Is integration in a system sufficient for consciousness? According to IIT it is. I don't think the story is quite that simple. I'm optimistic that we can make real theoretical and experimental progress on this problem. Perhaps we are still in the early days. Perhaps we're heading in the right direction. Do I need to get back to the drawing board? Hell, I never left the drawing board.